So Bezier curve is an approximation spline curve. So we know that your spline curve is two types. One is your interpolation spline curve and another is your approximation spline curve. Bezier curve, it belongs to approximation spline curve. It is also a spline curve, but it is of approximation type of spline curve. Second point, we can say that Bezier curve is a parametric curve. So we can say that Bezier curve is a parametric curve. If it is a parametric curve, definitely it will depend on your third parameter. The Bezier curve will be called as n-degree polynomial curve, provided it consists of n plus 1 control points. We can say that we can get n-degree Bezier curve from n plus 1 control points. If n equals to your 3, then this will called as third degree Bezier curve, or we can say that the cubic Bezier curve. In cubic Bezier curve, we'll have how many control points? 3 plus 1, 4 control points. So we'll have 3 plus 1 equals to 4 control points. So just imagine that we're having a control point here, another control point is here, another control point is here, and the control point is here. So we can find a Bezier curve by joining those control points. Right? So 4 control points. So I can say this is P0, this is your P1, this is your P2, this is P3. So using 4 control points, we can create a cubic Bezier curve. If n equals to 2, then we are going to have how many control points? So 2 plus 1, 3 control points. By using 3 control points, we can create a quadratic Bezier curve. So just imagine that. So total control points will be how much? So n plus 1, that is your 3. So 3 control points we are going to use for degree 2 Bezier curve. And how to look like? So 3 control point means, let me place 1 control point here, another is here, third is here. So I can generate here. Okay. So the Bezier curve was discovered by the engineer Bezier. That's why this curve name is given as your Bezier curve. And the Bezier curve uses one polynomial function that is called the Bunsen polynomial function. So we can say that it uses, the Bezier curve uses Bunsen polynomial as basis function. So let's go for representing your Bunsen polynomial function which is used in Bezier curve. So Bezier curve is nothing, that is the collection of your some control points. So I can place control point here, I can place another control point here, and I can write one more control point here also. Okay. So here I am having two control points. So this Bezier curve passes through the two points, that is called the P0, another is called your P2. So those control points which pass through the Bezier curve, they are called as your anchor. So you can say that this is your anchor and this is also another anchor point. And the P1 will be called as your handler. Now we can say that your P0, P2, they are control points, but that control points are called as anchor points, and P1 is called as the handler. It decides the shape of your Bezier curve, and Bezier curve exhibits the global control point. So what is the meaning of global control point? Because if you are going to change your any control point, it will change the shape of the Bezier curve. So if we say that those control points P0, P1, P2, they are having x coordinate, your y coordinate, x coordinate is x naught, y coordinate is y naught, z coordinate is z naught. Similarly, your P2 is having your x coordinate x2 and y coordinate is y2, z coordinate as z2. So any control point can be represented by a position vector P. A position vector P can be represented using the Bunsen polynomial function as, how are you going to write that, the P of u, because it's a parametric representation. So P of u equals to summation over I begins from 0 to the degree of the polynomial Pi, then the Bunsen value v I comma n of u. So the value of u is lying between your 0 to 1, and n is the degree. N is the degree of the polynomial. And the basis function b, what you are calling as Bunsen polynomial, which can be represented as bin equals to, I can write it as c of n comma I u to the power I 1 minus u whole to the power n minus I, where c is a binomial, where c ni is how much, that is n factorial by I factorial multiplied by n minus I factorial. Now if you are going to take n as your 3, then P of u can be written as, that is summation over I begins from 0 to 3 Pi b I 3 because n is 3 here of u. If you expand it, you will find that P0 B0 3 u plus P1. So P0 is the first control point, P1 is the second control point, P1 B1 3 u, P2 B2 3 of u plus P3 B3 3 of u. Now the position vector for your degree 3 polynomial can be represented as the equation say marked as your star. So I can write here your V03 of u. What is a bin? That is C of ni. So I can write that C of n is here 3 comma 0 u I is 0 1 minus u 3 minus 0 is 3. That is B03 of u value. So what is C30? That is 3 factorial. C3 is 3 factorial by 0 factorial by 3 minus 0, that is 3 factorial. So u to a 0 is 1. So I can write that 1 minus u to the power 3. So 0 factorial is 1, 3 gets cancelled. So I got the value as 1 minus u to the power 3. So that is a B03 value. So similarly I can find the value of B13 of u. So now you put that your C of n I. So C of n is 3, I is here 1, u to the power I is 1, 1 minus u to the power 3 minus 1. Now we can say that the value C31 value is 3 factorial divided by 1 factorial into 2 factorial. U to the power 1 is u and 1 minus u square. So 3 factorial is 3 into 2 into 1, 2 gets cancelled. So I will get that value as 3 u 1 minus u to the power 2. So this is the value of B13 of u. So fine. Similarly, we can find the value of B23 of u, that is 3 factorial divided by 2 factorial into 3 minus 2 is your 1 factorial multiplied with u to the power I is 2 multiplied by 1 minus I to the power n minus I, so 3 minus 2. Now I can write here, so 3 u square 1 minus u. So that is the value of B23 of u, that is 3 into e to the power 2 multiplied by 1 minus u. Similarly, can you find the value of B33 of u? Yes, it's quite easy. So 3 factorial divided by your 3 factorial into 0 factorial, 3 minus 3 is 0. So u to the power I is 3. So 1 minus u to the power 3 n minus I is 3. So ultimately you will get the value. So the whole 3 part gets cancelled. So the value is how much? U to the power 3 and 1 minus u to the power 0, that is 1. So you got that uq for the value of your B33 of u. Now we can easily represent the whole position vector pu as, right? So what is the equation of your pu? Now you can see here the position vector p is varying from 0 to 3 pi bi3u. So p0, the first control point, b03 value just we have calculated, put the value of b13, put the value of b23, put the value of b33 in the equation which is marked as star. Now we will get the complete position vector in terms of your basis function. Now, by substituting the value of B03, B13, B23, B33 of u in the equation which is marked the star mark, which is meant for representing the position vector in terms of Bunsen polynomial. So we can write here P0, B03 value is 1 minus u to the power 3 plus P1 multiplied by B13. So B13 value already you have calculated, that is 3u 1 minus u to the power 2 plus P2 multiplied by B13 B plus P2 multiplied by B23. So what is the value B23? Here we got that 3 u square 1 minus u plus P3 multiplied by B33 of u value, which is uq. So can I represent your x coordinate, y coordinate and z coordinate in the position vector? Yes, it is possible. So you can write here P of ux equals to P x0 x0 1 minus u whole to the power 3 P x1 3u 1 minus u whole to the power 2 plus P x2 3u square 1 minus u plus P x3 u to the power 3. Similarly, I can represent the y coordinate by using the derived equation. So P u y, I can write here P y naught 1 minus u to the power 3 P y1 3u 1 minus u whole to the power 2 plus P y2 3 u square 1 minus u plus P y3 u to the power 3. So this is the way we have represented the position vector for y coordinate. So can I represent the z coordinate in the position vector? Yes, it is possible. So by using the same derived equation, I can represent that P uz is how much? P z0 1 minus u to the power 3 plus P z1 3 u 1 minus u square plus, I can write here P z2 3 u square 1 minus u plus P z3 u to the power 3. Now we can easily find the position vector of x coordinate, your y coordinate and the z coordinate by using your equation what you have mentioned here. Let's solve one numerical Bezier curve control points are P0 is given as 4, 2, P1 is given as 8, 8 and P3 is given as 16, 4. So question is, what is the degree what is degree of the Bezier curve? Second is, what are the coordinates at u equals to 0.5. So first question, what is the degree? the solution we can say that how to find the degree. Degree is nothing, the number of control points minus 1. So here we have P0, we have P1, we have P2. So we have 3 control points. So that's why the degree will be control points are P0, P1, P2. Hence, degree will be how much? Degree will be n minus 1. So 3 minus 1, 2. So the degree of the Bezier curve will be 2. Second is find the coordinates at e equal to 0, 5. So first I will find the x coordinate, then I will find the y coordinate. So for that purpose I have to use the your position vector p u, that is summation I varies from 0 to n. So n is a degree is 2 p I b I 2. So let's expand it. P0 B02 plus P1 B12 plus P2 B2, 2. So P0 is given 42, P1 is given 88, P2 is given 164. So I need to find that B02, B12, B22. So B02 value I can write here, that is you know that value, that is your value is how much. Let me show you the, now you can see that I am using this star mark equation. So for the purpose I am going to use B02, B12, B22. So Bin value Cni u to the I 1 minus u whole to the power n minus I. So that value I am going to use. So I can write here B02 as 2 factorial divided by 0 factorial into 2 factorial u to the power I e to the power 0 1 minus u to the power n minus I 2 minus I value 0. So we got that 1. Now the value will be how much? 1 minus u to the power 2. Similarly I can find B12. B12 is your n factorial 2 factorial divided by I factorial, I is 1 multiplied by, so 2 minus I 1 factorial into u to the power I 1 minus u to the power 2 minus 1, that is 1. So ultimately you get the value 2u 1 minus u. So that is B12. Let's go for B22. So the value of B22 is 2 factorial divided by 2 factorial into 0 factorial u to the power I is 2 into 1 minus u to the power n minus I. So 2 minus 2, that is 0. So how much it is? 2 gets cancelled. So I got the value u to the power 2. Now I will find your P u x coordinate, P u x. So as per my equation, let me show you the equation for your x coordinate. Px0 1 minus u to the 3, Px1 3u into 1 minus u to the power 2. So this equation I have to use Pux. Now, so can I write that your value will be x0 into B02 of u plus x1 B12 of u plus b x2 B22 of u. Okay. Now your x naught is the x value of first control point P0. So P0 is x coordinate. So as per my question, what is given to us? x naught is 4, x1 is 8, x2 is 16. So we can write here x naught value. So x naught value is already I told you the value is your 4. B0 value we have calculated 1 minus u to the power 2 plus x1 value I have shown you that is 8 as per question, that's 8, and B12 of u, the value that we got, that is 2 u 1 minus u, already we have derived it. Then x2 value 16 into B22u value is u square. Now your u value is given as your 0.5, b value 0.5. Now put the value, u is given as 0.5. So by supplying those values, so you will get in that x coordinate will be 1. Similarly, you can find the value of your y coordinate. So this equation already you discussed in your derivation part of your Bezier curve. Now you apply this equation. From this equation you substitute the values only. So y0, y1, y2. So these are the y coordinates of your first control point, second control point, and third control point. So once you substitute the value of y coordinates, then already we have calculated the value of basis functions b02, b12 and b22. Substitute the value, and u value is given in your question, that is 0.5. So by supplying all those quantities, you will find that expression value as 5.5. So x coordinate value is 1 and y coordinate value is 5.5. So that